It's going to be a discussion of converting trigonometry from a unit circle to trigonometry of a right triangle, which I find more useful in a roundabout way than the unit circle definition. So the first thing we're going to start off with is we have two concentric circles. They share a common center, and we're going to put a random angle in here. Let's just call it, theta for good standing. And the inner circle is our normal one unit circle, radius of 1. And the outer circle, it could be a smaller circle, it could be a larger circle, and I'm not even worried about what it is and what its radius is. So we're going to deal with this angle here going through both of these circles. It's a central angle for both of them. And the first thing we're going to do is we're going to draw two triangles. One of them is going to be here. We're going to drop down a altitude. We're going to have this little small purple triangle based on the unit circle. And then we're going to have a larger triangle that's going to be based on the larger circle, and or smaller, depending, but in this case it's larger. So we're going to have this one. We'll call it the orange triangle. And what's true about the purple triangle and the right triangle, number one, they're both right triangles. Number two, they're similar because they share this common angle theta over here near the center of the circles. So since the triangles are similar to one another, they are also in proportion. Alright, so if I label the purple sides, the little ones here, we'll just call this one x and we'll call that one y. So the coordinate of this point is just xy. And if I label the orange ones as x prime and y prime, then the coordinate of this point is going to be, x prime, y prime. Alright, so if these triangles are in proportion to each other, we can set up proportions that look something like this. We can write, oh, I forgot one, the radius, or the hypotenuse. In this case, this one is 1, because it is on the unit circle. The other one, we're just going to have to call it r. Whatever that radius is, that'll just be plain old r. So we can set up some proportions. For instance, we can say x over 1, so we're talking about this small length x on the purple side compared to the hypotenuse of the small one, is going to equal the same side that corresponds with this little x, which is x prime, over its radius, which would be r. So I know for sure that x over 1 is equal to x prime over r because the two triangles are similar to each other. But I also know that x is equal to cosine of our angle here, which is theta. So normally we would just say cosine of theta is equal to x on the unit circle, but if it's not on the unit circle, it's going to be this x prime over r, this side of the triangle over this side of the triangle. Alright, we can also set up a ratio of y over 1. So we're talking about the purple side here, y, over its radius, which is 1, or its hypotenuse. Well, that's going to be equal to this side, which corresponds with the y here, which is y prime, over its hypotenuse, which is r. So we're going to get y prime over r, but y is equal to sine of theta. We also can set up the ratio y over x, and this would correspond to y prime over x prime, and this would equal tangent of theta. So now if we just concentrate on the orange triangle itself and our angle theta down here, we have so far that cosine of this theta is equal to x prime over r, sine of theta is equal to y prime over r, and tangent of theta is equal to y prime over x prime. That's nice, but it gets kind of confusing, especially with r changing. So if I just wanted to look at the triangle itself, concentrating on where this angle is, I can give names to these x prime, y prime, and r, get it out of a coordinate system, and just talk about the triangle itself. So let me erase a few things here. Let's get rid of x prime, and we're going to replace that with kind of a location. It's next to this angle theta. It's touching this angle theta. We're going to call this side adjacent. And let's get rid of y prime. It's not touching the angle theta, and it's actually directly, a nice description of it would be opposite. And then finally, this r, it already has a name. It's the hypotenuse of this right triangle. So we can rename the cosine or reorganize the cosine theta, sine theta, and tangent theta. And I'm going to start off with sine theta by convention. So sine theta generally was y prime over r. Well, y prime is now called opposite, and r is now called hypotenuse. And then cosine of theta was x prime over r here, but x prime was replaced with this adjacent, and it was over its radius, which is now called the hypotenuse. And then finally, tangent of theta is going to equal y prime over x prime. Well, y prime was this side, which is opposite, and x prime is adjacent. And there's a couple of different ways of memorizing this setup. One of them that I never could do, that my teacher showed me, was the Indian name, so sine is equal to opposite over hypotenuse, which is cosine adjacent to hypotenuse, toa, which is tangent is opposite over adjacent. But being me and being a horrible speller, I could never remember that, so I came up with an acronym. Mine is a little funny, and I've seen it in many, many places lately. I don't know how it got there, but mine is some old hippie caught another hippie tripping on acid. I know it's not very kosher, but it works really well. And you need to memorize this so we can start using right triangle trigonometry.